will switch to English. So I'm going to talk about data and how to work with data and how to use data to get at information. And that process involves what is called data wrangling. Sometimes it's called data engineering or data preparation, cleansing, filtering, enriching, and aggregating. Those basically all apply to the same activities. It's to get data to a state where we can start the real analysis and visualization. And of course, there are many tools available for doing so, many different technologies. But the one that I stumbled across about 2.5 years ago, and um, that I really like a lot, is the Jupyter Notebook. And it uses Python and it uses a library called Pandas. And in this session, I would like to show you what Jupyter Notebooks are and maybe not so much convince you as well as inspire you to also start using them. And you will find them anywhere basically. Most major cloud vendors are also using either the Jupyter Notebook or a similar concept in their data science and data analytics environments. And a little bit about myself. As I said, I'm from the Netherlands. I would have liked to be with you in Nuremberg, but of course, that's what we all would have liked. I'm currently in my attic in Zoetermeer, which is close to The Hague. I work for Amis. It's an Oracle partner that was started in 1991. I wasn't there at the time, but I've been there now for 18 years. I'm the CTO, and I'm also a cloud solution architect when I go to customers, because of course they don't really care about me being a CTO. I'm an Oracle Groundbreaker ambassador and have been ACE director since 2008, I believe. So, last week I attended Gartner's IT Symposium, and I had to do a presentation the other day to present a summary of this symposium. And you might be wondering, why am I talking about Gartner? Well, this was my data visualization challenge. When I tried to create a summary of this symposium, I did a number of searches in this symposium's website. So I searched for Java, no sessions on Java, not a real surprise. I searched on database, no sessions on database. I searched on architecture, 11 sessions on architecture. I'm starting to get somewhere. On strategy, 49 sessions on strategy out of a total of 140 sessions, I believe. Future, 56, and then COVID, 29. So what I was trying to get at was an overview of all the topics that were relevant at this symposium. As part of my report on this conference, I would like to present a tag cloud that looks a little bit like this one. But how to create it? Do I have to perform all these searches in the website myself to find all the terms that are meaningful and then draw a tag cloud myself? Well, of course not. There are tools that will help me with this. And the process that I had to go through to get from Gartner's website to this tag cloud using Jupyter Notebooks, that's what I'm going to tell you about. But first, of course, we have to do a little bit of introduction. We're talking about data here. And as I said before, in order to get the information, the insights, eventually maybe even the decisions based on data, we have to go through a number of steps. We have to gather the data from the external sources, in my case, the Gartner website, and store that data somewhere. And at some point, the data is ready to be used, to be shared, to be published, to be visualized. But in between, we have this process sometimes called data engineering, data preparation, or data wrangling. It's like wrestling with the data to get it into the right format, into um, the right the right shape, the right aggregation level. It has to be clean. It has to be complete. It has to be trustworthy. Perhaps it needs to be enriched. Perhaps it needs to be aggregated. And when we have that, we can get to our results. So we have to gather data, wrangle data, store the data in that process. And then finally, we get to explore the data, analyze data, visualize and publish the data. Now we're going to look at some of the technologies that are available for going through this process. So here is the same flow. We go from raw data in external sources through what we sometimes call a data pipeline. We gather the data into our data lake, data warehouse, database, data store, object storage, um, a store for data. And then we go through the wrangling process to get our data into the right shape for performing the actual analysis. So we store the data again after wrangling it, and then we can start the exploration, analysis, etc. And as I said, many technologies available for each step in this flow. And I'm not going to discuss all these technologies. I'm just going to show you that there are many technologies, both in the open source domain and from various vendors, both on-premise and in the cloud. And I'm sure that there are names in these lists that are familiar to you. I'm also pretty sure that there are some names that you've never heard about. And to be honest, there are many names that I don't know too much about myself. So I'm going to focus here. I'm going to focus on specific technologies that are very popular, very versatile, and available almost everywhere. So we're going to work with Python. We're going to work with Jupyter Notebooks. And in this particular case, I'm going to use JSON files as my data storage because that's easy. So you may be wondering why Python. And to be honest, until 3 years ago, I'd never worked with Python. I'd known about Python, but it didn't really appear in my scope. I was working with Java and JavaScript and PL/SQL and SQL. Python actually is one of the most popular programming languages around, as you can see from this chart. Python is the black line, and it's increasing, and it's now surpassing Java in popularity as measured by TOAG. And it is in a contest, of course, but it's just an indication of how popular Python is. Some of the advantage of Python, well, clearly, as you can see here, to do similar things in Java and Python, in Python, it takes way less code. Now, of course, I'm kidding here. This is just to show you that Python is a regular programming language. There are some sounds in the background. Could you all mute, please? Um, Python is very easy to learn how to work with it, how to read the code. It's far more intuitive than many other programming languages. So it's very easy for beginners to get started with it. And the focus with Python is it's it's very pragmatic. That may not work for all use cases, but it certainly works for many use cases, including the one that I'm discussing today. And it basically means that it takes very little time and effort to write the thing that you're trying to create. As I said, Python runs almost anywhere, and there are many resources available. That's what you get from being such a popular programming language, of course. Python has become the most popular language specifically among data scientists and people involved in machine learning and all kinds of data analysis. It's sort of a head-to-head competition with R, but it seems like Python is winning that race insofar as it even is a race, of course. And here are some of the uh, best known libraries in the Python ecosystem for working with data. And I'm, I'm going to show you today Pandas, Matplotlib, um, and the other ones are certainly also worth checking out. Among Python libraries, one stands out, and that's the top line here, and that's the line for Pandas. And with Pandas, you may think about the cute little bears from China, but actually, in this case, Pandas is for panel data, um, and panel data basically is a spreadsheet. The Pandas library in Python allows you to, in many ways, manipulate data that you can regard as being in a grid, in a spreadsheet-like structure, and work on it, manipulate it. And for those of you who are also working with SQL, it will look like SQL or at least feel like SQL in many ways, but it allows for more programming and more leveraging of rich libraries for text analysis and machine learning, model training, and other fancy stuff that are not as easily available in SQL. So I'm going to show you pandas. I shouldn't be talking too much about them. Um, Basically, in any project involving data analysis, data pre-processing or wrangling or data engineering typically takes most of the time to get the data into the right shape, to make sure it's complete, to make sure that it has high quality, to make sure that it is enriched and aggregated at the right level. That takes by far the longest time. And pandas are extremely powerful to support you with that. As I said, it feels like a spreadsheet. It looks like this. A pandas data frame is a set of records, and each record is composed of columns. And hey, am I just describing a relational table? And it certainly looks and feels like it, and yet it's slightly different. For example, columns in a panda can be nested themselves, um, which is not as which of course not so common in SQL, even though the Oracle database has the object type as a base type for columns. Okay, I've sort of introduced Python, a programming language that's very popular, very easy to use, and very well suited to work with data. And I've very briefly very briefly introduced this library, this pandas library that apparently is also very good at data and that allows you to manipulate data as if it were a relational table. Would it now not be great if we had a tool that works like a wiki, that allows us to jot down ideas, experiments that we want to perform, experiments that we have performed, and the findings? We're working, after all, in the data science lab. And that would also allow us to include code snippets, and that can even execute those code snippets, load data, and manipulate the data right there. So it's a combination of documentation and lab reports and the actual work we're doing. And if this tool now also would support Python and Pandas, because apparently these are the technologies best suited for working on data, for data engineering, visualization, and machine learning, would it not be great? And of course, such a thing exists. It's the Jupyter Notebook. A notebook, as I was just introducing, is a document, a live document that can contain a combination of code and rich text, including tables, equations, images. So you can edit an article, but this article, your technical article, is alive because it can contain code that can be executed, and it also contains the results from executing the code. And I will demonstrate this in a moment. So it's ideal for storytelling. Your data is used to tell a story, and your notebook tells that story, is your report of how step by step you, from the raw data, you arrived at your conclusions, your findings, your charts. Jupyter, by the way, and I only learned this last week, is an acronym for Julia, Python, and R. And all of these are programming languages. And the Jupyter Notebook does not only work with Python, it can also work with Julia and R. And at this point, there are also kernels available in many other languages. So even though today I will be showing you Jupyter with Python, you could also use a Jupyter Notebook with another kernel in another programming language. So even though I'm talking about Jupyter Notebooks, there's actually a slightly different umbrella now that's called Jupyter Lab. And Jupyter Lab was released formally just over a year ago. And that was the extrapolation or extension of the Jupyter Notebooks that were started in 2015. And that they then were the next generation of IPython or interactive Python, which had been started in 2001. So we're standing on the shoulders of giants here. As I said, Jupyter Notebooks are included in many cloud vendors offerings. So, for example, the Oracle Data Science Cloud Service on Oracle Cloud Infrastructure, also on Azure Databricks, as well as in AWS and in the Google Cloud Platform. Also some environments where you can work with the notebooks for free, in addition, of course, to running it just on your laptop. The sites mybinder.org and Notebook Viewer, NB Viewer. They both allow you to work with notebooks. And by the way, if you upload a notebook to GitHub and then look at your notebook in GitHub, you will see that GitHub knows how to interpret a notebook, and it will um, present a pretty view. What you see is what you get view of the notebook. Now, in order to work with notebooks, you can of course go to a cloud environment, or you can run it locally. And my demo today is run locally, and I'm doing so by by running a container image. That's something I didn't have to prepare. It's available to me. And in this container are Jupyter Lab, are the Pandas library, and are Python, the Python runtime environment. This simple command, and I have pasted this command into the chat window for this session. Using just this single command, I get to run my Jupyter Notebooks environment on my laptop, provided, of course, there is a Docker engine available. It will take a few minutes because it's downloading quite a large image, up to a gigabyte. But just execute this command, go away to have a coffee. When you return, your environment is running. You can then open your browser. In this case, I've mapped the internal port 8888 to my laptop's port 10,000. So when I open the browser at 10,000/lab, this is what I get, my notebook environment. And by the way, the work directory inside the container, so that's the one I'm seeing here in my Jupyter Notebook environment, is mapped to the working directory from which this command was executed. So the present working directory is mapped to this work folder inside the container. Okay, let's take a look at Jupyter Notebooks. So I'm switching now to my notebook environment, and as you can see, it's running against the container. I'm not, well, I could show you the container as well. This is my Linux environment, and here the container is running. And I could create a new notebook. And as I said, it looks a bit like a wiki. New notebook. I'm just typing text. And now I'm adding a cell, and in the cell, I can type code and I can execute the code. And I can add another cell, change its type to Markdown. Here, first example, and write a little bit of Python. And execute the Python as well. So this is the basic idea. You combine your nodes, your Markdown style nodes with code snippets, and you can execute the code snippets and see the result of executing the code snippets. Let's take it to the next level. Go away, and this is familiar data, at least for you, for those of you who have worked with the Oracle database. This is basically the contents of the EMP table. And now instead of using SQL to work against this data, and of course, in this case, the data is inside CSV file, I'm going to work on it with a notebook. And this is a notebook I prepared beforehand, but you immediately see there are cells here, and each cell is either text or code. And for example, this code will read from the CSV file the data into a Pandas data frame, and HR is my Pandas data frame. So let's execute the code, and it will show me the first 5 rows of the Pandas data frame. It looks like a table, looks like a spreadsheet, not spectacular, but this is my starting point. Once I have a data frame, I can do many things. First of all, I can inspect the data frame. I can get an overview of its contents, or I get an overview of the types of the columns, or I can get an idea. Let's copy and paste this code. I can get an idea of all the different values in a specific column and their occurrence. I can do the same thing with salary and know that 2 salaries appear twice. Not extremely important, but it's the starting point. And it's important to realize that once the data has been loaded, and by the way, the notebooks are not suitable for gigabytes or terabytes of data. Um, the final processing of huge data lakes is not done inside the notebook environment. But you can take all the code that you have created inside a notebook and publish it as a service that you could run, for example, on Apache Spark, that could be run against a data lake. So the notebook itself is where you will work with a sample, a subset of your data, but the results, the code that you create, that you craft, the machine learning models, for example, that you craft in your notebook can be published and can be used for a larger environment. So here I'm converting the date as a string to date as an actual date um, data type. And here I'm using a very interesting feature of the Pandas data frame. That's the cross tab. And it allows me to create cross tab, a table, with one column used for the rows. It's like the pivot command in SQL, if you are familiar with it. And so I can easily get an overview of the hire dates of the employees working in the various departments. But in this case, the statement HR, that's my data frame. I want to group the data frame by department number. Then I want to take the values from the cell column and I want to find the max. Well, you wouldn't be surprised to learn that this results in getting the maximum salary for each department. And here I'm getting the salary sum for my HR data frame, and I'm grouping by department number and job. As I said, it's very similar to what you can do with SQL. It even looks a bit like SQL, but of course it's completely different. And in this situation, we have far more opportunities for programmatically interacting with the data. So let, let's run it. And you you probably expected this. I'm grouping by department number and job, and for each combination of the two, I get the sum of the salaries. One of the things you can easily do inside a notebook is create charts. And here I'm going to create a bar chart. And in this bar chart, I'm going to see the sum of the salaries, and I'm going to see it by department number. So I'm expecting 3 bars, and each bar should give me the sum of salaries. So let's execute it, and there we go. And of course, there are many ways to improve the layout of the chart. Add titles, add a legend, change the colors, change it into three-dimensional, add uh, Hoover text. This is just a very simple and basic example. You can also do filtering. And again, the similarity with SQL continues. It's like a where clause. In this case, from my HR data frame, get me all the salaries over 100, where the job is equal to clerk. I don't expect too many rows. Oh, actually, there are a few, 3 of them. And if I change the condition, it's only 2. It doesn't surprise you, but it's quite powerful syntax. Learning how to work with the Pandas data frame gives you tremendous power inside your notebook. There are some other examples. You can combine various data sets. So in this case, I'm also reading departments data from the depth table, obviously, but now stored in a CSV file, another CSV file. And here I create a combined data frame that consists of all the data from the original HR data frame, the employee data, combined with the depth data frame, and I perform a join. Um, so from the HR data frame, I take the depno column. From the depth data frame, I also take the column called depno, and it's a left outer join. So even if a department is lacking from the department's file, I still want to keep the employee. And here's the combined data set. As you probably know, when we do data analysis, we don't care about uh, normalization. In fact, we do the opposite of normalization on our data. And it continues with another interesting map which can easily be created. It's a heat map that gives an indication of the number of people in a certain job on a certain location. So, for example, in Chicago, we have a high concentration of salesmen because it's dark blue and dark blue indicates four. So this is the hotspot for salesmen, and we don't really have any other hotspots. Two analysts in Dallas, not important. So that's a quick introduction of the notebook. Let's now apply the notebook and what it can do to my original quest of what's the Gartner Symposium about? Eventually getting to the tag cloud of all the important terms of this Gartner Symposium. So where do I start? This is all I have, the website. And on this website, I see details for sessions and I can search for sessions. So you could consider now a screen scraping strategy. And screen scraping basically means that instead of you yourself going through a website, you create a little program that goes through the website on your behalf. And then that reads text that's on the website. That can be done, but it can be hard. And that turns out to be an easier way. So when I perform a search in my browser, in this case, I search on fragrance, what's what's happening behind the scenes in your browser when you press Ctrl Shift I, this is what I see. There is a URL being invoked, and in the post request, well, there are a number of request headers, and here is my search term. So it seems like there is a REST API that's being invoked by the client side of this website, and this REST API, well, if the if the web if the web application can invoke it, then perhaps I can invoke it myself. The response to this request, by the way, is a JSON document that contains all the data that the website then will present to humans. But of course, this is structured information that I can certainly use as the raw data to feed into my data lake. So when I go about analyzing the data for the Gartner Symposium, what I will be doing is I will get my raw data from this REST API. And I don't think it was intended to be used by me. So you could discuss the ethics of this. But then again, screen scraping would certainly put a higher load on the backend systems. Me doing a single request to get all the information about all the sessions in one go is not such a high load. So I think it's okay. I don't feel bad about it. So I have this data gathering stage. That's my first notebook. I have my data wrangling stage. That's my second notebook. And once the data is in a good enough shape, I can start doing business intelligence. And I will have two avenues of doing business intelligence. One is on sessions and one is on speakers. So again, I'm going to use a Jupyter Notebook for gathering the data, for storing the data locally, for a second notebook for wrangling the data and making it suitable for business intelligence, and then a third notebook for the speaker evaluation, visualization, and reporting. I'm also using a third-party library to do uh, gender guessing. I would like to know how many women and how many men are presenting, but I don't have the gender for the speakers. But from the first name, I probably can guess the gender. So that's a third-party library that I'm making use of in my Jupyter Notebook. And then I'm also doing explorations on session data. It's basically the same story again with a little bit more detail. So now let's go over to my notebooks for the data from the Gardener Symposium. Once again, I'm in my Jupyter Notebook environment. And by the way, I will share all this code with you. So this will be available in a GitHub repository. The first step, so this is the step where I'm gathering the data. And as I said, there is a REST API. And if I feed these headers to the REST API, it knows that I'm asking for data from the Gardener Symposium event. And I can also pass my search criteria. If I don't pass any search criteria, I will get information about all the sessions, or at least the first 500 sessions. In this case, there are only 160 sessions, so this basically means get me all sessions. So here's the code, and if I execute the code, it's now calling out to the API, and here it's returning the result. So this is the JSON data returned from the API for, well, basically all sessions taking place on this Gardener Symposium. Actually, this is not, oh, and I'm printing the first 4,000 characters from that response. So here's the code, and I'm not going to discuss the code in detail. Basically, it's still the single HTTP request. And when the response is in, I'm already slightly wrangling the data because the sessions are in the response are clustered inside section list elements. And that's the kind of nested structure I'm not interested in. So in order to get it all into a single list of sessions, um, I'm, I'm executing this little bit of data wrangling. And then finally, I'm loading the JSON data into a Pandas data frame. And the end result is a data frame. So if I execute this cell, that of course is not what I was hoping for. I first should have executed this cell. I should have executed this cell. That's a live demo for you. There we go. So now I've got a data frame with all the information about the sessions from this Gardener event. And some of the information is very clear and accessible, like the title, and some information is still nested. So for example, times and attribute values both start with a bracket, and that indicates that the data inside it is actually an array, and that array contains additional nested structures. So in my next little step of data wrangling, I have to try to get the information from that nested structure. Here, as a final step, I'm writing out the information to a single file, and that single file is in my data lake directory, and I can open it here. And this is the file that contains all the information about all the sessions. So for example, here are all the titles. And I was talking about the attribute values. Where are they? So you can see that that still is a nested structure. Attribute values, there we go. So this still is a fairly complex structure, which we will deal with in the second notebook. Discard changes. So the second notebook, that's where the real wrangling takes place. We get the raw data from the local data lake, from the JSON file that I was just showing you. That's the first step here. That's loading data from the file. and you can see it's really easy to load data from a file into a data frame. It's basically read JSON from what's the name of the file um, into the pandas data frame. And now SS for, I'm not even sure what it stands for, or it's my own name. It now contains all the data on the sessions. Sessions, that's probably what it stands for. So the shape is 136 rows. So there are 136 sessions and 44 columns. And some of these columns are nested. That's the total amount of memory used by my data frame, 400K. That's okay. 4 megabytes would be okay too. 4 gigabytes would start to be a problem. Here's a list of all the columns. Here's a list of all the types of all the columns. And I'm not going to go this in detail because we don't have time for that, but just so you can understand how, as a data engineer, you would use your notebook and the pandas library to get a feel for the data. So here, for example, I'm looking at a count of all the values in the column type. And I could also have used values count. I just realize, except of course, never change your mind in the middle of a running demo. In this case, there are some attributes in my data frame, some columns that I don't need. So I'm going to get rid of them. It doesn't, of course, remove them from the underlying JSON file. It just removes them from memory. I get a list of the current state of the data. I'm getting more information about the types, as we saw before. And in this case, I want to get an overview of all the different values that appear in the length column. It's like select distinct column name from table in SQL. And here it's done against my pandas data frame. So we have sessions of 20 minutes, 25 minutes, 40 minutes, 30 minutes, 45 minutes, and we have the following session types. Again, you understand that this is a very easy way of discovering, exploring your data. Taking a look at the nested column of attribute values, and here I'm looking at the value for this column for the 11th row in my data frame. And here's the information in that nested column. That is quite a lot of information. Turns out that from here I can get information about who the session is for, um, what topic the session is about, and what industry the session is discussing. So I'm now going to create new columns in my data frame based on the information in the attribute values nested column. So for example, I'm going to create a new column that's called Gartner speaker, and it either indicates Y or no, yes or no, to indicate if a speaker is working for Gartner. And I'm creating this column by applying a function across all of my data frame. This function is invoked for each row in the data frame, and for each row which represents a session, it will determine if among the session participants, there is at least one participant whose company name attribute is equal to Gartner. And if so, we have found a Gartner speaker, a session by a Gartner speaker, so we will set the Gartner speaker flag for this particular session. Of course, it's not hugely important exactly what we are doing here, but it's just to give you an indication how we can enrich our data in this data wrangling process uh, by working against our data frame. In the interest of time, I will quickly go to my third notebook, and in the third notebook, I'm taking the wrangled data. So now the data is in a shape that's suitable for starting our exploration and analysis, and I'm looking at information about the speakers. So it starts again with loading, in this case, the wrangled data set from JSON into the data frame, and then I'm going to get questions answered. First of all, how many different speakers are there anyway? 132 different speakers. Okay, and how many sessions are presented by each speaker. Well, it turns out to be um, one speaker who has a session count of four. Actually, it's a Dutch guy, Frank Buitendijk, and here he is. Um, so here I'm asking the data frame, give me the information for the record at the location where the where the record lives with the highest session count. And here's the information I get returned. What are the job titles? Well, I can easily get a list of job titles and now present those job titles in a tag cloud. This is the code. And the most important thing here is, well, that's not a lot of code to get yourself a tag cloud. And apparently there are many vice presidents at Gartner. Not really a surprise. So here's a list of all the companies the speakers are working for. Here's an overview of popular first names. And here is a tag cloud of those popular first names. Once you know how to create a tag cloud, you create them all the time. Here's my investigation into the gender of speakers. And I don't know the gender, but I can try to guess the gender. So I'm using one of the many Python libraries. And when I say many, I really mean many. There are hundreds of thousands of libraries. And this is one I can use for guessing uh, the, the gender based on the first name. So the name Jan, according to the guesser, probably is male. Lucas, I guess, is male too. Um, now, you you get the idea. And here I'm um, creating a new column called gender by applying this gender guesser function on all the records in my table. And in the end, I get an overview of, well, 70% male, 25% female, and 5% unknown. I'm also, by the way, trying to extract the gender from the speaker's bi biography by looking at words such as his or her. Very quickly, the final notebook. And in this final notebook, I arrive at long last at the tag cloud that I was talking about at the very beginning. So by analyzing the text of all the titles and abstracts, as you can see here, and by excluding from this analysis all these stop words, I can finally get an overview of all the terms and their frequency um, in all the sessions, and thereby get an impression of what this whole event is about. So starting from raw data, wrangling that data into JSON files, and then finally taking the information from the files, analyzing it, and visualizing it. This is the overview I get. And my last week of the Gartner IT Symposium was spent on talking about digital technology for business that lays out the future that CAOs should be aware of. That's basically what it was all about. There we go. So, my conclusion, data can unlock value. There's much value in data, insights. We can see trends. We can make decisions based on data. But in order to get at that value, we have to do some things. We have to gather data, raw data. We have to wrangle that data, get it into the right shape, enrich it, and then we start analyzing and visualizing the data. And this whole process consists of a lot of trial and error. It's like working in a lab. You have your hypothesis, you try something out, you may be right, but most of the times you're wrong, and that's okay. And data preparation and wrangling and exploring is something you will do over and over again. Python is the most popular language for doing so. Pandas is a very powerful library supporting that. And Jupyter Lab notebooks are a great workbench, as I hopefully have demonstrated in this session. The workbooks can be powered by Python and Pandas, but also other technologies and libraries. They're easy to use and they're most definitely fun to use. When you go out onto the internet, you will find tens of thousands of examples of notebooks that analyze all kinds of data sets, especially the Titanic data set. That's a very popular one to give you examples. So with that, I would like to thank you for your attention. I hope this has been useful. I will take a look at the Q&A just now. But before you go and leave, I want to wish you a pleasant day and a great rest of the conference. Thank you very much. And now I'm returning to the Q&A. Are your notebooks available in the web? Is a question asked by Torsten. And as I said, they are not yet, but I will make sure that they are available in a GitHub repository before the hour is out. So yes, they will be available, and I will then provide the URL in this chat if that still remains available. And otherwise, I will publish it as a tweet. Okay, so I think that has been answered. And I don't see any more questions and nothing in the chat. So I think that means we've come to the end of the session. Once again, thank you very much